So in this video, I wanted to talk just a little bit about percent change and how that works with an exponential pattern. And then in the next video, I'll talk a little bit about fraction changes, and then we'll go from there to looking at exponents that aren't whole numbers anymore. So the first one is I just want to talk about like a percent change. So for example, let's say I start out with $200 in the bank account, and let's say that I get a nice 5% interest rate. What that means is I take $200 and I multiply it by 5%. 200 times 5%, which is 0.05, just think of it like dollars and cents. 5% is like 5 cents. Multiply that, you get 10. And what that means is that after 1 year, if we're doing 5% per year, 200 plus 10 means there's $210 in the account. Now, to figure out how much there would be in the next year, the 5% is calculated on the entire $210. So we go 210 times 0.05, and that gives us 10.5. We take the $210 at the beginning of the year plus 10.5, and that gives us 220.5. So what I want you to notice is that the amount of money that you earn each year changes. It was $10, and then it was $10.50. The next year, it's going to be even more than that. It would be $11.025. So it's not like you're always earning $10. Your 5% is applied to a bigger amount each year, so your value of your money compounds like that. This is kind of annoying to have to do this two-step process every time. What we're really doing in each step of the process is we're taking our $200. So let me draw a line here. We're taking our $200 and we are multiplying it by 0.05 and then adding our original $200. What I want you to notice is that the $200 is in common, and you have your 0.05 plus 1. Now, what did I just do there is I just distributed out the $200. If you imagine distributing $200 back inside the parentheses, I hope you can see how you get the expression that's there on top. So in general, what we did is we did $200 times 1.05. Same sort of thing happens as we want to go to the next year. Now we have more money in the account. We have this amount of money in the account. So to figure out what we have in the next year, we go 200, 1.05 times our interest rate, plus 200 times 1.05 itself. So remember, this is how much money we have after 1 year. So we take the money after 1 year times the interest rate plus the money after 1 year. Now I can do the same factoring trick to get this expression. 1.05, because that's the part that's in common, 0.05 plus 1. But that's another version of 1.05. So what we end up with is 200 times 1.05 squared. In fact, what you'll see is that instead of doing it as two steps where you multiply by 0.05 and add it onto the original amount, you can do it in one step by multiplying by 1.05. The 1 represents adding on what you had at the beginning of the year. You get to keep 100% of your money. And the 0.05 is adding the extra 5% interest. So to generalize this situation, what you have is your original amount, and you have 1 plus your interest rate, raised to the number of years like that. Okay? You can also do this sort of thing with depreciation. So sometimes things go away over time. So, for example, if you have something like a used car, maybe you bought a car that was worth $20,000, good for you, and it depreciates at 8% a year. If that's the case, the way you can figure out how much it's worth after 1 year is 20,000 times 0.08. If you do that, again, 0.08 is just because 8% is just like 8 pennies. So that is 1,600. And then we can do 20,000 minus 1,600 to get 18,400. So after 1 year, your car is worth 18,400. But rather than doing it in 2 steps, you could have also equivalently done 20,000 times 0.92. And where did I get 0.92 from? Well, just on the previous example, I did 1 plus 5% to be 1.05. Here, the way I got 0.92 is I did 1 minus 0.08, or 100% minus 8% is 92%. It's the same idea. Okay. And just like before, I didn't have to always do it in 2 steps. I could always just take my 20,000 and multiply by 0.92 to whatever number of years I cared about. So if I wanted to know after 5 years, I just plug 5 in. If I wanted to know after 10 years, I just plug 10 in right there. And in general, your process is the same idea. It's just 1 minus r raised to the t. So that was just a little quick overview of how you deal with percent increase or with percent decrease. In the next video, I'll talk about how you deal with a fraction increase or a fraction decrease. And then we'll talk about what if the exponents themselves are fractions and how you can interpret that.